It's a word problem. It's got the devil's prefix. This could be really bad. We only have 5 minutes. All right, a box of volume 8 cubic meters. With a square top and bottom is constructed out of 2 types of material. All right, and it says the metal for the top and bottom is $50 per meter squared. $50 per square meter. And the sides cost $30 per square meter. Find the dimensions of the box that minimize total cost. Okay, so first thing you want to do is draw a picture. So we have a box with a square top and bottom. So that's handy because that immediately reduces one of our, instead of length times width times height, we just have like length times height, or width times height. You know, we have a square. So we could call x times h or something like that. And so we know that the volume is length times width times height, but here that's going to be x squared times h, and we know that that's 8 cubic meters. Now, we need to come up with a cost function, and it's going to deal with the surface area. We have the squares on the bottom and the top that cost $50 per square meter. So you have 2 x squareds, and then that, whatever that area is, because x squared is the area of the square, and you have 2 of them, that's going to be times $50, right? So if we had a cost function, we have the top and bottom is $50 times 2 x squared plus, all right, well, the sides, it's $30 times the sides, there's 4 of them, and it is x times h. Okay. All right, and so these functions are kind of, you know, doable. What we're seeing here then is that this we want to minimize cost, so we want to take the derivative and set it equal to 0 and find the critical number. But we can't do that when we have two variables like that. So we need to express h in terms of x, which we can do using this equation. Since x squared times h is equal to 8 cubic meters, we can say that h is equal to 8 divided by x squared. And then we can take that and pop it right in there for h. So our cost equation expressed only in terms of x, then, I'll just call it c, is going to be 100 x squared plus 30 times 4 is 120. Oh, and then x, and then we have an 8 and an x squared. So let me clean that up a little bit more. 100 x squared plus, all right, is that 960 divided by x? I think so. Are we okay with that? Yes. No, she's not okay. What happened? Uh-huh. Well, remember multiplication, you just multiply one thing. So it was on the x. The 30 times 4, 120. It's just, it is. You just multiply one time. It's not like with the addition, you know. Okay. So the derivative is going to be 200x, and then this is going to be minus 960 over x squared. And then we have to just get a common denominator. So we'll multiply this term by x squared over x squared. So our derivative is equal to 200x cubed minus 960 divided by x squared. And remember, you're only concerned, obviously it doesn't make sense for x to be 0, which is where your derivative would be undefined. So we also just want to know where the derivative is 0, which is where the numerator equals 0. So we'll have 200x cubed minus 960 equals 0. So get x cubed is equal to 960 divided by 200. And so x is equal to the cube root of 96 over 20. Let's see what that is. When you do a cube root, you know, you have to have it in parentheses if you're going to raise it to the 1/3 power. So about 1.69 or so. But we want to check to make sure that this is a minimum, so we should do the second derivative test to verify it's a minimum. So what we would do is we would take this value, this the critical number, cube root of 96 over 20, and we're hoping that when we put it in the second derivative, we get a positive number. Because if we do that, means it's concave up there, which means if it's a critical number and concave up, it must be a min. So if I look at the second derivative real quickly, I'm just going to take this, looking at this one. It's going to be 200 plus 960 times 2, which is, let's see, 0 to 1920 over x to the 3rd, right? And that is always positive for x is greater than 0. So this is greater than 0, which implies concave up, which implies x equals the cube root of 96 over 20 is a minimum. Do they want the actual cost? Okay, so we've got x. If you want to get h is equal to, is it 8 divided by x squared? So here it's going to be 8 divided by the cube root of 96 over 20 squared. So you can type that into your calculator. So it'll be 8 divided by 96 over 20 to the 2/3 power. So 2.8. So we say 1.7 by 1.7 by 2.8. We'll give you a box that will minimize the cost. Because these are meters. Okay, all right. Okay. I tried to post a lot of the questions. Hold on.